odd moving u to the numerator.
Is that right? Where did that come from? U over u squared is 1 over u. 1 over u squared is u to the minus 2. So ultimately now I can write out what v is. What will v equal? Well, maybe I shouldn't have used u here as the substitution, huh? I probably should have called it t, because we're kind of using u already over here. So this is t minus 1. So t dt, this is t squared, t minus 1 over t squared dt. And now when I separate, I get 1 over t here and t to the minus 2 dt. So this becomes 1/4 ln absolute value t, 1 plus 2x, plus 1 over t, so plus 1 over 1 plus 2x. Is that right? It doesn't matter to me how bad this is, because in the second part, we write uv. I don't have to integrate that now, do I? Minus the integral of v du. Uh-oh. Maybe I do care. Right, look at that. That doesn't look too good. Well, let's see what happens anyway. So this turns into now the integral of u times v, 1/4, oops, sorry. This turns into u times v, 1/4 e to the 2x times what? Ln absolute value 1 plus 2x plus 1 over 1 plus 2x. That's u times v minus the integral of v du. V du, so yes, this didn't work out either. Well, and this is what I was talking about last time. Well, I don't know about last time, but last week when I was referring to this chapter, you've got to be willing to not go with your first choice. So that isn't going to look too good either. That didn't work out very well. So is there any other choice for how I could set it up?
I just have a question. I could have done it the first way you set it up.
Well, that's what I'm saying. I'm looking for another choice now. So at this point now, I'm saying to myself, well, is there any other setup there that I could integrate? You have to understand that setting up dv is really the key. That has to be something I could integrate. Look at the numerator. Could this possibly work? We didn't try this, did we? I don't think that's a setup we used. Could that work? Well, yes, it can. We've already integrated that one, haven't we? How do you integrate this? With part. So let's try that now. This, you've got to be ready once you try one of these things to just totally abandon it. Now we should talk about that. If it's in the blue book and you just went through all this effort, suppose you decide you don't have any more time to spend on this problem and you're going to go on to the next one. When you do come back to it, or even if you don't really come back to it, what are you going to do with all this? Are you going to erase it? Or are you going to leave it there? Well, if you erase it and leave that problem blank, how much credit are you going to get? If you leave it there, I get to say, well, that was a good try. Maybe I can give you 4 or 5 points out of the 10. Right? You still don't get the problem because you didn't get the problem, but you can still get partial credit. So I don't like this. This didn't work out for me, but I kind of like that over there. So tell me now, if somebody asked me to integrate x e to the 2x dx, how would I do that? Now I'm going to make u equal x dv equal e to the 2x dx, du is dx, v is 1/2 e to the 2x. So this becomes u times v, 1/2 x e to the 2x minus the integral of v du, 1/2 e to the 2x dx. Did I do that right? uv minus the integral of v, where's v, du, so that does look good. And so this is 1/2 x e to the 2x minus 1/4 e to the 2x. We don't need the arbitrary constant because we'll add that on to the end. So now I feel like, well, who knows, this still may not be the right way to go, but at least I've got another thing to try. So the way that we set this up is we're going to let u equal 1 plus 2x to the minus 2 dv is x e to the 2x dx. What will du equal in this case? -4 over 1 plus 2x quantity cubed dx. Am I deliberately skipping some steps on you guys? You got to be able to do derivatives like this in your head. This is Calc 2 now, right? So that was okay, right? Bring down the -2. Derivative of the inside is another 2. That's where the 4 came from. And what's v equal to? Right there. 1/2 x e to the 2x minus 1/4 e to the 2x. So let's see if this is any better. So now we have u times v. That will be 1 plus 2x to the -2 times v, 1/2 x e to the 2x minus 1/4 e to the 2x. All of that is u times v minus the integral of v du. And now this one doesn't look too good. Oh, actually, this one may work out. v du times -4 over 1 plus 2x quantity cubed dx. So that one doesn't look any good either, does it? I guess it's not too bad because, no, it's still just as bad or worse than what we started. What was the first thing I wrote up there you thought would work?
X, yeah, x times, you make u equal x times e to the 2x.
Oh, so now I need to try it the other way around. Did I write that up there at all? I don't remember writing that one up there. That was the first thing, so the first thing looks like it was gonna work, huh?
For the first attempt, you just tried e to the 2x.
What did I try? So u equals x over 1 plus 2x squared?
No, it's x.
The other way around?
X
Just
times
x,
e.
yeah.
Oh, this one. Oh, I wouldn't have thought of that. I tried that at the beginning, and I didn't like that, huh?
But you didn't want to do the integral of that.
Because I didn't want to do the integral of that?
Yeah.
Oh, yes. We can do that integral, can't we? So the derivative here is the derivative of the first times the second plus the derivative of the second times the first dx. And here v, that's right, if I write this as dx over 1 plus 2x quantity squared. Well, I can even do that one without a substitution, can't I? I can write that as 1/2 1 plus, minus 1/2 to the -1. Oh, that did work. So that's I guess the first thing, the instincts kind of worked on that, but I wasn't looking carefully at the derivative at the integral I was about to do. I was thinking something else when I looked at it. So u equal x e to the 2x, let's try that. And dv equals dx over 1 plus 2x quantity squared. Yeah, we can do that without a substitution. And this is going to work? we'll find out derivative of the first times the second plus derivative of the second times the first. And then, goodness, dx over 1 plus 2x quantity squared. So v is, well, we already did it over there, didn't we? Minus 1/2 1 plus 2x to the negative 1. And let's try that one now. U times v is going to have the x e to the 2x in the numerator. And in the denominator, I guess we need the minus sign. In the denominator is 2 and a 1 plus 2x. Minus the integral of v du. And what do we have there? That doesn't, okay, I see where that's going to take us. So v du, we have e to the 2x plus 2x e to the 2x all over. And let's see. I got that, v du, we need the minus sign. Why don't we just leave the minus sign in there for now? And we'll put the 1 plus 2x there. So this one's kind of especially set up just perfectly that if you come up with the exact right substitution, things are going to work out. This is sort of an accident waiting to happen. And by that, what I mean is notice what happens when you factor out, not this 1/2 that I just did, but an e to the x from the numerator. So there's no way that anybody would have ever foreseen that. They had to set this one up just perfectly for that to happen. Sort of one of those unfair tricks I keep referring to. So now that's just 1/2 e to the x.
It's e to the 2x.
Oh, sorry, I copied it wrong. So in that case, if we integrate that, we're going to get 1/4 e to the 2x. And then we have this stuff, so minus x e to the 2x. And then we're going to add an arbitrary constant. This one was fairly bad. They get worse though, don't they?